Nobody taught the new model to recommend violence.
It learned it anyway from the last model's homework.
And the company that trained it had no idea until someone went looking.
The errors weren't in the code, they were in the inheritance.
The contamination framing misses the real mechanism. This isn't bad data producing bad outputs. The teacher model passes every safety benchmark you throw at it. The danger lives somewhere the benchmarks don't reach. And the student model still picks up the unsafe behavior.
And the student model doesn't even need to see a single dangerous sentence. The unsafe tendency is encoded in patterns. Which requests got longer responses, how refusals were phrased, tiny statistical textures spread across millions of otherwise ordinary outputs.
Researchers ran distillation experiments where a teacher model had been fine-tuned with deliberately embedded unsafe tendencies, willingness to help with weapons instructions, that kind of thing. Then they trained a student model purely on the teacher's outputs, sanitized outputs. The teacher never once produced an overtly dangerous response during the training process.
And the students still learn to be unsafe in the same ways, not because it saw anything dangerous, because the shape of the language carried the pattern forward, the way certain requests got slightly longer responses, the way refusals were worded with just enough hedging to leave a door open, none of it visible line by line, all of it visible in aggregate.
Which means the entire audit playbook is calibrated for the wrong problem. You're scanning individual outputs for individual bad things. The risk is in the aggregate shape of millions of normal things, and no one has a tool that reads at that resolution yet.
And this isn't a hypothetical pipeline. Distillation is everywhere. It's how smaller companies build competitive models without spending hundreds of millions on compute. You take outputs from GPT-4 or Claude or Gemini, you train a smaller model on those outputs, and you get something surprisingly capable for a fraction of the cost. Meta's original Llama paper acknowledged that synthetic data from larger models was part of the process. It's industry standard.
So every model trained this way is a student of a student of a student, and nobody has a full chain of custody on what got passed down. The researchers use the phrase subliminal transmission, which sounds dramatic until you realize it's precise. The student model can't tell you why it behaves the way it does. The developers can't point to a training example that caused it. The behavior emerged from a pattern no one can see and everyone is copying.
And the next generation of models is already being trained on data that this generation produced. That's the inheritance problem. Here's something that arrived from a completely different direction. Something showed up in the solar system last month.
There's a comet passing through our solar system right now that didn't come from our solar system.
3I Atlas, the third interstellar object we've ever detected. The first two were 1I Oumuamua back in 2017 and 2I Borisov in 2019. This one showed up and immediately started doing something neither of those did. It's dumping water. Tons of it, every second.
Enough to fill 70 Olympic swimming pools a day, just vaporizing off the surface as it gets closer to the sun.
And normally when a comet does that, it's interesting, but it's local news. It's our water from our solar system, from material that condensed around our sun 4.5 billion years ago. This water is from somewhere else entirely.
A different star, a different planetary system, possibly one that's older than ours.
Which means the chemical signatures in that water vapor, the specific ratios of hydrogen to deuterium is hydrogen with an extra neutron in its core, which makes it heavier and chemically distinct. Those ratios act like a chemical fingerprint that tells you where the water formed. The types of organic molecules riding along, all of that is basically a core sample from another star's neighborhood delivered to our doorstep.
And the spacecraft that caught it is JUICE, the European Space Agency's Jupiter Icy Moons Explorer, currently on its way to Jupiter, and its instruments happen to be in the right place to measure the outgassing as 3I Atlas came through.
A spacecraft designed to study alien oceans on Jupiter's moons accidentally got first crack at alien water from interstellar space.
The first two interstellar visitors, Oumuamua in 2017 and Borisov in 2019, were gone before we could do much more than watch. Atlas is different.
And nobody sent this, nobody aimed it, it's just falling through, leaking chemistry from a place we'll probably never visit.
A free sample from a star system we can't even name yet, and it's evaporating.
There's a telescope in Arizona called DESI, the Dark Energy Spectroscopic Instrument, and it has 5,000 tiny fiber optic cables that each lock onto a different galaxy at the same time.
5,000 at once. That's not a telescope, that's a net.
Every 20 minutes, it repositions and grabs another 5,000. It was supposed to take 5 years to complete its survey. It finished early. And the result is a three-dimensional map of 47 million galaxies, the largest map of the universe anyone has ever made.
When we say three-dimensional, we mean you can see where each galaxy sits, not just on the sky, but how far away it is, so you get the actual structure.
The structure that falls out of that data, the cosmic web, is something like the skeleton of the universe, long strands of galaxies called filaments stretched between vast empty regions called voids. That's what the map renders in 3 dimensions. And the reason it matters is dark energy. So the universe is expanding, and about 25 years ago, scientists discovered that expansion is actually accelerating, getting faster over time. Nobody knows why. The placeholder name for whatever is causing it is dark energy. It makes up roughly 68% of everything in the universe, and we have essentially no idea what it is.
The leading assumption has been that dark energy is constant, same strength everywhere, same strength at every moment in history, baked into the geometry of space the way the speed of light is fixed. Einstein actually built this into his equations under the name cosmological constant, which is a term for a fixed energy density that space itself carries.
DESI's data is suggesting that might be wrong, that dark energy may be changing over time, weakening.
Which would mean the universe isn't just expanding faster, it's expanding faster in a way that itself is shifting. The rules aren't fixed.
And if dark energy is weakening, the long-term fate of the universe changes completely. The scenarios physicists have mapped out for how everything ends, heat death, the Big Rip, those depend on dark energy staying constant.
So either the models need rewriting or the data has a flaw nobody's found yet. DESI's next data release is already being processed. If the signal holds, the question of how the universe ends gets a lot less settled. Federal prosecutors just charged 6 people with smuggling NVIDIA chips into China, billions of dollars worth, the same smuggling Jensen Huang called tall tales less than a year ago.
Southeast Asian data centers have been quietly acting as a pass-through. Chips go in restricted, come out the other side in Chinese hands.
And enforcers are catching maybe a fraction of it. The rules exist, the enforcement is something else.
What makes the timing strange is that US and China trade talks are happening right now. High-stakes, public handshakes.
While underneath that, the actual federal prosecutors just charged 6 people with smuggling NVIDIA chips into China, billions of dollars worth, the same smuggling Jensen Huang called tall tales less than a year ago.
Southeast Asian data centers have been quietly acting as a pass-through. Chips go in restricted, come out the other side in Chinese hands.
And enforcers are catching maybe a fraction of it. The rules exist, the enforcement is something else.
What makes the timing strange is that US and China trade talks are happening right now. High-stakes, public handshakes.
While underneath that, the actual hardware rivalry is running through a completely different set of channels.
The rules are written in one language, the hardware moves in another. Over 100 published AI studies built stroke and diabetes prediction tools using the same health datasets.
And those datasets show signs of being fabricated, not flawed, not incomplete, possibly invented.
Some of those models are already running in hospitals.
Medical AI goes through layers of review before anyone trusts it with a patient. That's the assumption.
Except nobody checked whether the training data was real before the studies were published, before the models were adopted, before any of that.
A prediction tool is only as honest as what it learned from.
And right now, there's no clean way to know how many tools built on those datasets are sitting in clinical software somewhere making calls.
Bitcoin developers are proposing that if you don't move your coins to new quantum-safe addresses, the network could lock them permanently.
You'd still own them, you just couldn't spend them.
The concern is quantum computers, machines powerful enough to break Bitcoin's current encryption and let someone else drain your wallet before you can react.
So the proposal is essentially move or lose access, a hard deadline built into the protocol itself.
And Bitcoin has never done anything like that. The whole premise is that your keys are yours, and nobody, not developers, not governments, can override that.
This would be the first time the network itself could effectively close the door on someone who holds the coins but missed the window.
And how the community votes on it will say something real about what Bitcoin actually is.
Microsoft patched 165 security flaws last month, second highest single-month total in the company's history.
Researchers think AI tools are why the numbers keep climbing. They find bugs faster than human teams can review or fix them.
One of those 165 was a flaw in SharePoint, already being actively exploited by attackers before the patch existed.
So the window between discovery and fix is shrinking, but the window between exploitation and fix apparently isn't.
If AI keeps accelerating how fast vulnerabilities get found, the security industry's model of patch and move on starts to look like it was designed for a slower problem.
We'll be back tomorrow.
A lot is moving, more than fits in a day.
That's always been true. It's just more visible now.
See you then.
I'm Knox. Every Saturday on Pulse Deep Dive, one story, the history, the present, and what comes next. Find it wherever you listen.
Singularity Pulse is for informational purposes only. Nothing here is financial, legal, or professional advice. Views expressed are our own.